Hey, what's up guys? So today we're going to make a video on data, how to handle data with Python. And the project is going to be called hrbro. And for that, we're going to divide the project in multiple steps. So the first step is going to be creating the environment. Second step is going to be about looking at the data and kind of looking at the data, kind of trying to figure out what kind of data structure makes sense. Then the third step is going to be about creating the importer. The fourth step is going to be about creating the API in the views. After that, we're going to use Pandas to, manipulate data. After that, we're going to, these two steps are actually reversed. After that, we're going to be creating some tests. So we're just going to create basic tests just to make sure that our calculations are meaningful. After that, we're going to go with documentation, because your code should always be documented. And with Django REST framework, it's very easy to generate some Swagger documentation and redoc documentation. So we're going to go through that. And after that, we're going to containerize our app. Okay. So these are the steps that we're going to go through. First, creating the environment in the project. Second, looking at the data and thinking about what kind of structure we want to use. Third, creating an importer. Fourth, creating the API and some basic views. After that, we're going to use Pandas to create some more elaborate views. And after that, creating tests, then documentation, and then containerization with Django. Okay, let's make it happen. Okay, so now we are in PyCharm, and we're going to start by setting up the environment. So the first thing we're going to do, of course, is to install Django and Django REST framework. Okay. Second step is going to be about actually starting the project. We're going to call it hrbro. We're going to get in. And our app is going to be called HR API. Okay. Cool. So let's see how this looks like. There we go. We have here our little Django project with the main folder, which has the same name than the project, and the actual app, which is going to be HR API. Okay. Now let's add this. Let's add our app in install apps. Okay. And we're going to create a URL file. So this is our URL file that's going to be in HR API, where we're going to have all our different paths with the different views. Right now, I'm just making it very basically. It's just so that I don't forget to import the views over here, because we want to include all the API views in this folder, and we're going to call like API, and here we want to use include. Okay, and here we're going to be doing something like this. Okay, so that means that we want to have all the URLs from the HR API app. Okay, and we're going to define the different URLs here later. Okay, so this doesn't really need to make sense right now. Okay, cool. We're going to run python manage.py migrate now. Okay, and this is creating a SQLite database this is just for testing purposes, because at the end of the project, when we're going to containerize the project, we're going to use Postgres, which is going to require us to change a little bit the settings here. But right now, just for the purpose of this video, we are just going to keep it simple with SQLite. Cool. So we're in the migrations. Let's just make sure that the server is running fine. Okay, our server's over there. Let's actually go and run it. And even though it's a page not found, it's actually working, because here we can see that it's listing our different endpoints with admin and API. We're not going to go in admin yet, because I didn't create any super user, and I'm not even going to create any super user for this tutorial, because we don't need it. Okay. But now the project is working. So the next step is going to be creating the models for HR API. And for that, we're going to look at the data that we're going to import. So that's the next part of this video. Okay, cool. So now we're going to look at the data. So that's how our data is going to look like. We have an ID, first name, last name, email, gender, date of birth, industry, salary, and years of experience. So obviously we will want to have industry related statistics. And based on what I see here, what would make sense is to have two tables, one for the employee and the other one for the industries. And then we are going to use a foreign key to link the industry field from the employee table to the industry table. Okay. Here for the first name, last name, we're going to use strings, string fields. Here, email field. Gender is going to be probably not a Boolean, but a choice field. Date of birth going to be, a date field. Salary, a float field. And years of experience, an integer field. So let's go and create that in our project. Let's delete all that. So first thing first, we're going to import the models. And then first we're going to start with, we mentioned industry. Okay. We're going to give it a max length of 100 because I don't see why the name of an industry would be longer than that. And after that, we're going to create the employee model. Okay. So first name, last name, email, date of birth. What else? Email, gender, industry, salary, years of experience. Gender, industry, salary. First name is going to be a char field. Same thing, max length is going to be 100 unless you have a particularly long name. Last name, same thing. Here, email field. So for emails, now the question is, do we want to allow two users to have the same email? For me, it just doesn't make sense because it's literally impossible for two different persons to have the same email. So we're going to make it unique. Okay. Same thing, 100 max length. There's no reason to be longer than that. Okay, so for the industry, we're going to use a foreign key pointing towards our industry table. On delete, I'm going to put models set null. And what's going to happen is that if this is pointing to, I don't know, to the all industry, and we delete all industry, well, all the employees which are associated with the all industry are going to have null for the industry field. Other than that, usually with Django, we're using onDelete cascade. And what happens when we do that is that if the industry is, for example, oil, and I put cascade, and we delete the oil industry in the database, well, all the employees which worked in the oil industry are going to be deleted as well. And we don't really want that right now. We're going to allow it to be null as well. Salary. So we want a decimal field. There's no reason why we should allow more decimals than that, especially for salary. Okay, max digit 10, unless we're talking about Elon Musk. I think that they're not going to have a bigger salary than that. And years of experience is going to be an integer field. Now, one of the questions that I asked myself is, we could make this couple of fields unique. There's a way in Django to say, we don't want to have two employees which both have the same first name and last name. But if you really think about it, in certain countries where people have the same name and the same family name, and in very, very big companies where you have, I don't know, tens of thousands of employees, there is a probability that we're going to have two employees with the same name and surname. So even though that could be a choice, we're not going to make that choice right now. But I just wanted to mention it. Oh, and something else, we're going to create that def_str function. When we print the employee object, it's going to output what's in this function. So I want to output self first name and obviously self last name. Okay, cool. So now we have our models. Next step is going to be running the migrations. For that, we're going to go python manage.py make migrations. Oh, we have an issue here. That guy. Okay, it's been creating our fields. Blah blah blah. Yeah, he's not happy with that because I have 2 times this thing. Okay, so to solve this, we're just going to, for now, we're just going to copy paste this and give him some valid URL so that he can let us in peace. But all this is going to be replaced in the next step of this video. Okay, so now our migrations have been applied and we're going to open that. Now we can see that all of these tables are automatically created by Django, right? But the 2 tables that we have personally created are HRAPI employee and HRPR industry. Of course, right now we don't have any data in it. This is going to be the next step of this video where we're going to create the importer. Okay, so now we have our models created, we have our database running, we have our migrations applied, our project is running, and the next step is going to be about importing the data. So here I have my mock data file. I'm just going to move it into my project so that it's going to be easier to set the path for the importer. It's over there, mock data. So to import this data, we're going to create a Django management command. So you will see in the Django documentation that to create management comments, you need to follow a predefined path in your folder. You need to create a management folder and then a commands folder. We're going to create it in the HRAPI directory management, and inside management, another one called commands. Okay. I'm going to copy paste their boilerplate code and then modify it in my project. Okay, we're going to call it importer.py. So again, here there's a kind of a fixed structure. You need the 2 main functions that we're going to need are add arguments and handle. Handle is basically what's going to happen, what the kind of the function we're going to trigger when we trigger that management command. And add argument is going to be whatever argument we want to add to that command. Okay, our apps is not called pulse, it's called HRAPI. Import questions. No, we don't want any of that. Well, he's not happy with something. Import. What's the matter? It's in both. Finally. So industry employee. Okay. Import the data from a specific file. Parse argument, we're going to specify the file path, obviously. We're going to give it a type and a help. Okay, and now the handle function. So we're going to delete all of that. Let's go with creating that handle function. So first thing first, we need to import a bunch of things right now. Import pandas as PD. We're going to also need datetime. From datetime, import datetime. We're going to need some error handling. Okay, sorry, it's a green error. And we're going to use the math module. Pandas is not installed yet, so let's install it. So now we're going to create a data frame. So we're gonna use that from JSON function, which is going to use our options file path, which is this, to read from our JSON file. And then we're going to handle so what this does is that it's going to look for places in the data frame where data are missing, and it's going to replace it with known. It is going to make it easier for us when we have to write in our database. For example, if there's a field that's missing, it's going to know that it has to treat it as a known. Okay, now, so okay, let's make a pause here. We're going to iterate through, go through the data frame and use the data that we find to fulfill our database. So basically, what we want to do is to create employees. Okay, so employees have first name, last name, email, gender. There you go. Reformat. Okay. Here's a small error as well. There you go. So that's kind of the basics of our program. Of course, if we run it like this, we're going to have a lot of different errors. So the first thing that we want to be thinking about is handling the date. Okay. And for this, we're going to create a format date helper function. Okay, so date object. Cool. And then it's going to be the y. Cool. And after that, formatted date object y and d, and return formatted date. Now, actually, that's going to be mostly useful for the date of birth. Okay. And here, we're going to change it that way. There you go. After that, remember that we said that industries are a foreign key. So what's happening is that we want to make sure that either the industry already exists and we're going to use it, retrieve it and use it, or it doesn't exist and we're going to create it. And for that, there is a very useful function from Django called getOrCreate. That's actually inside the loop. Okay. The reason why I'm using this is that this function is not going to return an industry. It's going to return a tuple where the first value is the industry object and the second value is true or false. And we don't really care about the second value right now, so we just want to be using that industry. Cool. But then there's another challenge, because if we look at the data frame of the JSON file, we'll see that some of the industry, let's check it out, are NA. So NA is not exactly null. We would have to handle this NA, and we're just going to use an if statement for that. So I'm using this so that we can handle all different scenarios. Okay. Okay. getOrCreate, employee industry, and then we have the industry. And then if it's not the case, it's going to be known. The next challenge is going to be about handling the employee salary. There are going to be places in the data frame where the salary is going to be NAN. And to handle that, we're going to use, again, an if statement. salary employee salary. If not, and that's why we're using that math module. So it's not for crazy math calculation or whatever. Okay. We don't necessarily need to. Okay. So if the salary is not NaN, we use it. If it's NaN, then it's just going to be known, and we're going to place it here. There we go. Cool. Notice that I have imported the integrity error, and that's because sometimes you will have employees which have 2 times the same email, and we have decided to make email unique, so that's going to trigger integrity error, and we want to bypass them. So, oh, we forgot about this too. This has to be moved to here, industry. Okay. There we go. Integrity error pass. Okay, or we could make a print statement like, and if we are successful, we want to, I like when I'm running an importer or any kind of script, I like to see what's happening in the console. So we can add something like that. So if the import is successful, we print this, like, I don't know, successfully added John. And notice that here we have this index. So we can use that to know where we're at. And this is the total size of the data frame, so that we can have an idea of our progression. Okay, so the next step is going to be about running that importer. Cool, so let's start running the importer. Importer. So the way we structure this management command is that basically here, this is the name of this file, which have to be right in these folders. And then we can add the argument that we have created here. So file path is going to be, for us, just going to be mock data. So you have a bug here. That's actually read JSON. Let's do it again. Another one. User expected a number but got a NaN. And that's because we should have handled it that way as well. Now the reason why we have this, notice that here at the beginning we kind of try to replace the values in the data frame using this function, but sometimes in the data frame we can have places, for example, where it's expecting a particular data type, and it's not accepting known. For example, it wants a float, and it's not going to it's NaN, like not a number, and it's not going to replace that number by known because known is not a float. And that's what's happening with the salary and the years of experience. And that's why we have to handle it again here to make sure that if we still have some values which are NaN, they are being treated like a known. Let's just call it years of experience. And replace it here. Let's run it. There we go. And now we can look at our database. And they're all there. All our employees. So the next step is going to be about setting up the API to display this data. Cool, so far we have completed the 3 first steps. We have set up our Django environment, our Django project. We looked at the data and determined an appropriate data structure. We have created and run an importer using Django management comments. And now we are reaching the 4th step, which is about creating the API and the views. Let's go. So the views are going to happen here. And the two first views that we're going to create are going to be pretty simple. In fact, we're going to be using class-based views. We're going to use model view set, and I'm going to touch on that in a second. Okay, industry view. We obviously need to import a bunch of stuff. Okay. We're going to give it a query set in a serializer class, which we didn't create yet. We're going to touch on that in a minute. Okay. Of course, we need to models import employee history serializer. Okay. And here's the same thing with industry. So the reason why we're going to be using model view set is that it's a very convenient and powerful view from DRF. If you look at the generic views offered by DRF, we have a lot of them. Okay, list model, create model, retrieve model, list API, retrieve API, destroy API. We have a lot of different models and views, mix-ins. We have generic views, API view. All of them are very sweet, very cool for different use cases when we want to customize stuff a bit more. But model view set, when you're starting out, you're creating an MVP or you just have your model set up in the project and you just want the API to run. Model view set is basically going to do everything under the hood for you. And all I have to do is to, write this, right? And give it a query set in a serializer class. Okay, so let's go and deal with the serializers. Okay. So, import serializers, and from models, import industry, employee. Okay. Class, we're going to create an industry serializer. Again, model serializer is just going to pick up. Actually, I'm sorry. Earlier, I said that this was the model view set that was handling the validation. Actually, it's the model serializer. And all you have to give it is a model and specify the fields that we want to use. And right now, we're just going to return all the fields. We don't need to. And you can also customize the fields. You can customize the way they look, modify them, whatever. But right now, there's no reason for us to bother with that. Let's just return all the fields. Employee serializer. And again, class meta as well. Here, we're going to be using the employee. Okay. We can go back on our views. And these two serializers are what we're using here. Of course, we need to import them as well. HRPI, serializers, import, employee. What's wrong? There we go. So we have our basic views set up. We have our serializers set up. And the next step now is to create actual URL path for our HRPI app. So the first one is going to be, so again, here, normally what we could do, and we're going to do it later, but we would have to specify the path for each view. But Django is doing everything for us because we can use something called a router. And what routers do is that you just give them a view set, and they're going to generate automatically or dynamically the endpoints for you. And it looks like this. Okay. And then we're going to register these. Okay. And just by doing so, I will be able to go /employees and get the list of all the employees, and /employee/ID to retrieve one particular employee, or do a post request to /employees to create employees. Okay. Now, let's register them over here. Okay, cool. So now let's actually, well, test this API. Let's run the server. Okay, cool. He is just giving us the different URLs. Let's go to API and employees. Oh yes, so that's happening because I forgot to put REST framework here in the settings. Let's add it here. REST framework. Let's refresh the page. There we go. So, but this is a get endpoint. Again, this endpoint has been created dynamically by the router, and it's just making by default a get request because. And we can see here all the different employees, right? Again, I could take any employee, ID is number 6, for example, and add it here. And it would give me data about that particular employee. And that's all generated dynamically by the router. Okay, same thing, delete is over there. We could also post a new employee. Let's for example, let's try to create a new employee. So what I'm going to do is that let's take a random employee, and I'm going to click here on raw data, and that's going to give me this that I'm going to be able to copy paste in my Postman app. Postman is kind of an app to make, well, API calls, API requests. We don't need, usually you would have to make post requests to come here and select the kind of authentication that you want to use, because for any kind of normal app, you need to be authenticated to make post requests. But we didn't specify any kind of authentication for our app, so we can just make post requests without authentifying ourselves. Okay, so that's going to be our URL. And in the body here, let's go with raw JSON. That's why I copy pasted all the data. The URL is going to be that one. There we go. Employee. Well, we're not going to use the same ID because that wouldn't make sense. First name is going to be JSON, and last name is going to be born. And that's going to be JSON born. Okay, cool. Let's create it. Oh, that's interesting. Method post is not allowed. Oh yeah, of course, because we're not making a push request, we're making a post request. So let's change that. Cool, it's over there. And it's returning us the data of the newly created employee. And that's what we can see here. But let's try something else. What if I try to create a new employee with the same email address, right? We can change his name, his family name. We should have an error. See, the employee with this email already exists. And that's because Django understands, based on the fact that we have a unique constraint on the email, that we cannot make a post request for a new user, a new employee with an email address that's already existing. And this validation is made completely automatically by Django because of the model serializer. Okay, but now let's try maybe something else. What if I try to use some incorrect data type? So we're gonna modify his email address, but now the problem is going to be that I'm not gonna use an integer for user experience. I'm gonna use a word, 28, for example. 28. That's going to be double quotes, not single quotes. There we go. And let's see if we have some kind of validation happening here. There we go. A valid integer is required. So we can see that validation is working fine. Post requests are working fine. Get requests are working fine. Everything's working fine. We now have two basic views. Well, basic. They're not really basic. They didn't take a lot of code, but they are very powerful because of Django REST framework. But we have two CRUD endpoints for both our employees and our industries. The next step is going to actually be, about using Pandas to make some sorts of calculation some averages, render the data in a particular way. And that's where the interesting / tricky part comes in. So let's move to that. Okay, so in this step, we're going to perform some calculations of the data to try to get some insights from it. We're going to create a general statistics stats. We're going to create a general stats class. We're going to define the get. Okay. And this is where the magic is going to happen. First things, we are going to retrieve the employees from our database using Django's hrbro. Now, the reason why I'm using this select related industry is that if I don't do this, what's going to show up in the API is the ID of the industry. Because remember, from the employee's perspective, the industry is a foreign key, so it's an ID. So select related is going to go the extra mile and look for the industry table to catch the industry object and bring it to our query so that we can get information about the industry, such as the name, which is what we're going to do. Next step is going to be about using Pandas. So let's create a data frame, employees, values. And the reason why here I'm going to use values is that if I don't do this, basically the reason I'm doing this is so that I can have a customized industry field, as you're going to understand in a minute. Gender and industry name. He figured it out. Okay, so now we have our data frame. Now the next thing, as we said, we want to have the average salary, the average years of experience, and the average age of these employees. The thing though is that we don't really have their age in our data frame so far. We have their date of birth. And their age, we have to be, well, calculated using their date of birth. And for that, we're going to create a helper function. Let's put it right above. It will be a bit cleaner to put it in the utils file, but right now we're just going to put it a bit above. Get age, date of birth. Okay, now, date time now. And age would be now year minus date of birth year minus now month, now day. I'm sure you can figure out the logic behind this. Playing with dates and ages is never really fun, but it has to be done. Yeah, okay. From datetime, import datetime. Cool. We have our helper function. And now we will want to apply that function on a particular column from the data frame. So this, we're going to go at this. Age. Adding age column. So pretty simple. We are taking the date of birth column and we are applying the get age function on it. Okay, that comes from Pandas. And that's the new column that we are adding to our data frame. Okay. And now we're going to actually start gathering insights from the data. So first thing we're going to do is to use the group by method from Pandas, which is going to group the data by industry. And then we're going to use aggregate. And we're going to pass a dictionary to aggregate. Salary. And the way this works is that, and the way this aggregate works is laid out here in the documentation. We can give it a function, a string, a list, or a dictionary, and we are obviously giving it a dictionary, and we're telling him to apply the mean function on these columns. So grouping by industry and then aggregating and finding the mean for each one of these fields. The next step is going to be about using reset index. And the reason for that is that when you're using group by on a data frame, it can change the index and it can kind of mess up the data frame. And to use the default index, we have to use the reset index method. After that, we're going to order the values using the salary. We want to know which industries are giving us the best salary, right? So assuming false, we want to start with the most lucrative careers and then go down the list. Okay. We're going to turn that into a dict so that it can be JSONized. Return response data. There we go. We need to import this as well. Okay, cool. So now we have all that. Let's try to import that in our URLs. Let's try to see what it does. General stats. Okay, so the parameters that I just returned, I forgot the return statement here. Pretty dumb mistake. Okay, let's go. Oh, stats. There we go. So now we have a list of industry with their name, the average salary, the average years of experience of their employees, and the average age of their employees. What I'd like to do, though, is to format this value a little bit better, because that's not necessarily very insightful to have so much decimals after, in particular for this field. Okay, imagine someone having 19.461538, whatever years of experience. Doesn't make sense. So we're gonna do some rounding here, and I don't like the fact that it says industry underscore names. So we're gonna format that as well. Reason why I need to say as type float here is because salary is a decimal field. And if I don't put this, it's going to trigger a bug. But for years of experience, it's not necessary. And here, age is not necessary as well. And we're going to round it to 1 decimal. It makes more sense. That's not the right place for that. That's why it wasn't red. Cool. Okay, so we have all this being handled. And we wanted to rename industry name thing. Okay, let's see the result. Of course, now I have to change this as well. It's just restarting the server. There we go. Much cleaner. So which are the top industries to work at if we want to make money? Coal mining, oil and gas, agricultural chemicals, 215. So now that we have these general stats, we are going to want to dig a little bit deeper and get some more tricky statistics about this data set. That's the next video. So for the next view, the question that I wanted to answer is, are older people being paid better or worse than the younger counterparts given the same amount of experience? Meaning, obviously, if the guy is 50 years old, usually they'll have more years of experience, which would explain why they are earning more. So what we're going to want to do is to create some brackets where we're going to have, let's actually draw this in a dashboard here. We would want to create some brackets where we want to know, for example, for the 20-25 years old with 5 to 10 years of experience, 10 to 20 years, 20 to 30 years, how much do they earn? Okay. And then we're going to compare that with, say, the older dudes, 50 to 55. And again, same years of experience bracket. So that's years of experience right there. Okay. And see if with the same amount of experience, who is earning more? Okay. Are they earning more or are they earning less? That's the question we will try to answer. And for that, we're going to use something called bins. So let's make it happen. We're going to call that new class years of experience stats. Again, an API view. Customize the get. Get our employees again. Creating our data frame. And you'll notice that here, I don't specify all the values because we don't need to deal with this industry thing. So we just put values, and it's going to put all the values by default. And now we're going to specify what's called bins. So those are going to be our brackets. We're going to create brackets of 5 years. So 0 to 5, 5 to 10, 10 to 15, etc. And more than 30 and more than 30. Okay? We're going to define some labels for them. Now understand that in Pandas, the way these bins work is that it includes 0, but it excludes 5. So if a guy were to have exactly 5 years of experience, it will be in the 5 to 10 bracket, not in the 0 to 5 bracket. But because it's easier to understand, for the labels, I'm going to go with 0, 5 and 5, 10, etc. But if the guy had 5 years of experience, he would be in that bracket. These are going to be our labels. Okay. Now the next keyword that we're going to use is cut. Let's figure this out. See how it works. Cut is what's going to allow us to use segments. Use cut when you need to segment and sort data values into bins. Blah, 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 blah. Okay? You get the idea. So let's see how it works. Pandas, cut. And we're going to segment the years of experience column using the bins that we've just defined and the labels that we've just defined as well. Okay? And that'll cut these data using these predefined bins. Okay? Now we're going to look at the salary by experience. And for that, we're going to do a group by on the experience bracket that we've just created. And we're going to apply the min function to the salary column. Okay? After that, same type of formatting that we used above. And again, we used group by, so we need to reset index. Again, response data, salary by experience. Let's turn that into a dict. Let's turn that into a dictionary. So I always specify the orientation, but that's not really necessary. I could just remove that and it will still work. If you want to know more about how orientation works, again, look up in the documentation. Okay, let's review that. We are fetching the employees from our database. We're creating our data frame, then defining our bins, defining our labels, using cut to create experience brackets. In these cuts, we're using the years of experience column. We're using our bins, our labels. Then now that we've created an experience bracket column, we are doing a group by on it, and we are applying mean to the salary. And then we are doing the, we're rounding up, we are resetting index, and we're turning that into a dict and displaying it into the API. So next step is going to be about adding that to our URL patterns path. Oh, sorry. Let's go with years of experience stats. Well, actually, you know what? So what I said earlier was kind of out of context. This is not the view that we've been building. We're building, this view is about giving us, it's an information that's much more straightforward. It's just giving us the average salary per years of experience bracket. So it has nothing to do with what I said before with this kind of concept of trying to figure out if older people makes more money or less. This is going to be our next view. Sorry for the misunderstanding. So this has been registered. Let's import it and go with that. There's a problem again. Can't import name. Really? Why not? Views. Using stats. Oh, wait. It's not at the right annotation level. There we go. So now we can see that, well, it's kind of counterintuitive, but it looks like the 5 to 15 years of experience bracket is actually the most lucrative. People start making a little bit less money, then they make more, and then as they grow, they make a little bit less, and then even less, and then even less. And then, surprisingly, those who are in the 25 to 30 years of experience bracket are making suddenly more, and then more than 30 less. That's what we can conclude from this data, right? Is that there is no particular. So these data are basically telling us that there is no correlation between the years of experience and the salary. Some people make more, some people make less, and usually people make a bit more between 5 and 15. We could try to add here a field, for example, telling us how much pieces of data have been included in the calculation to see if the average is meaningful or not. Because maybe that, see, usually here we could see that it's starting low, then increasing, then low again, and suddenly increasing again. But maybe this is kind of an outlier. Maybe there's like 1 or 2 employees in there which are skewing the data towards that direction. So we don't really know how much items have been used for these calculations. And another insightful piece of data would be to know how much people are included in each bracket. But that's not the point of this video. Okay, so for this video, we are going to actually do the age thing. So trying to figure out if younger people or older people make more money when they have the same amount of experience in a company. Let's go, let's create that. Maybe I should make a bit more place here. Okay. Let's call it age stats. We are, again, fetching our database, creating our data frame. And now we're going to be dealing with age. So again, we are going to use our helper function, get age. And we're going to create beans again. Age beans, 30, 40, 50, 60. Let's actually go with just more than 50. Oh, I forgot 40. Okay, year beans. Okay. And in the next section, we're going to chain multiple cuts within a group by. No, that's useful. Okay. So let's try to explain what's happening here. We're going to reorganize it to be a bit more efficient, right? That way it might be more visible and easier to explain. Okay. We are passing a list in group by. Let's read what group by is doing on Pandas documentation for a better explanation. Okay. So as you can see here, it says if a list equal to the selected axis is passed, the values are used as is to determine the groups. So here, let's check out the groups that we're giving to that group by. We are making a cut on years of experience using year beans, and we're making a cut on age using age beans. And we're using these two cuts within the group by to tell Pandas to make groups according to these cuts. And then we're taking the salary column and applying the main function on it. We're going to see the result of that in a second. But first, so now we're going to create a nested dictionary in order to display the data in a more appealing / beautiful way. Let's create our master dictionary. We're going to go through the results. Okay, years of experience. Okay, age, years old. I'm going to explain this whole function as soon as I'm done writing it. Not in response data. Response data, years str. Response data, years str, age str, and some rounding. Okay, so here we're creating a master dictionary. Then we're going to go through that result data frame that we just created, and then we're going to create some strings for the years, the age, and for the salary, we are going to use that year age tuple to retrieve the salary from the result data frame. And the reason why this looks like this, to make a good explanation of why, you would have to see how the data frame looks like, but this is where the salary is within that data frame. After that, if we don't find years str in response data, it means that we're reaching a new bracket. So we're creating this new bracket by adding it to the master dictionary, which is over there. Okay, and after that, we create the salary, which is going to be again response data, years str, age str. It's going to be we're going to round it. Okay, so understand that the salary is kind of two level deep into the dictionary, and that's why we have to do this and we have to do that. Okay, and the reason why I'm using float here is that for the same reason that I've been using as type float there. Okay, otherwise the rounding will not work. Okay, I understand that I might be explaining that function a bit fast. Again, I'm not sure if there's a better way to explain it. Okay, then we return response data. What's wrong? Oh, we forgot to define the get function. Okay, cool. Now it's about using these, importing it there, and creating a new endpoint for it. Let's go with age stats. And it's broad daylight because yesterday I actually had to go to sleep. So let's keep going. So we're talking about this age stat import. We are importing it in our URLs. And now we're going to just run the server and check out this endpoint. Age stats. Okay. So as you can see, we have our different brackets, 0 to 5 years of experience, 5 to 10, 10 to 15, etc. And within each of these brackets, we have the age of the employees, right? 20 to 30, 30 to 40, 40 to 50, etc. And that's kind of giving us insight on, well, do older people or younger people make more money with the same amount of experience? Now, what I don't really like with this data is how it's formatted. You can see that this is the default formatting for a range or an interval using Pandas. There's a parenthesis over there and a bracket here. It's not really looking good, so we will find a way to format this data a bit better. Let's make it happen. Let's go back in our views. We're going to add this function next to we're going to call it prettify brackets. And we're going to use the replace function. We don't want to do that. We want to replace this with that. And we want to replace to infinity with plus. Thanks. Right, this is a bit better. There you go. There you go. So we have now our prettify brackets helper function, which we're going to use here. Sorry, this prettify brackets. Okay, let's see the result. Oops, it's not TP. It's 2. There we go. And see now the data looks much better. 0 to 5 years of experience, 20 to 30 years old, 30 to 40 years old, 50 plus years old. Let's try to take a look at this data. Let's try to analyze this data and get some insights. So, for example, if I have 0 to 5 years of experience, well, I would say that within that bracket, the 40 to 50 years old age bracket is by far the most lucrative, 148,000, whereas the other brackets are pretty similar. People from 20 to 40 years old are being paid the same, and after 50 years old, kind of the same as well. Okay, so we are back in our views.py file, and we're going to create a view to get some insight on gender-related statistics. Defining the get function, getting the employees from our database, building our data frame, and now we will want to do something similar, because again, we don't want to be just asking, hey, are women or men making more money? I think it makes more sense to analyze within each bracket of years of experience, because I don't know, maybe that for some reason women or men are entering the workforce later, so perhaps you'll find some kind of wage gap, but this might be explained by how much years of experience this or that gender has or hasn't. So we'll try to do something similar than what we did with the age. We would want to compare men and women which have the same years of experience and see if who is making more money or if there's no discernible trend. And now we're going to a group by. Again, we're going to give it a list and then a cut. We explained earlier how cut works. Again, you can look up in the Pandas documentation, specifying the years bin. What's missing here? Oh, this one goes over there. Okay. And on that, we're going to look at the salary and apply mean on it. It's actually mean. Okay. And then we do the reset index. Notice that each time that we do a group by, we have to do reset index. So I've separated this line of code like this so that you can really see what goes into the group by. But of course, we could make it a little bit shorter, like that, while maybe something like that would be shorter. Okay, that's a bit better. And after that, we are going to do another group by, and we're going to use the apply method, which is going to run a function on the different cells of our data frame. And now we're going to do another group by, and we're going to use the apply function, which is going to apply function by definition on the element of our data frame. And we're going to pass a lambda function, and we are turning it into a dictionary again, and then returning the response. So here, what are we doing? Let me explain. Because of the way we've been grouping the data here above, we're going to have something like that. We're going to have something like male, and then data, 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 like bracket, then bracket, data, 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 and then female, bracket, data, 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 bracket, data, 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 etc. But within this group of data, if we don't use this drop function, we will see male again each time and female again each time, which is kind of redundant, right? Because we are already in the male category, the male section of that nested dictionary. So we don't need to re-specify each time male. And that's why we are going to apply this drop function on axis 1 on the gender column, so that when the API displays the data, we don't see these anymore. We just see the bracket and the salary. You'll see that in action in a moment. Okay? Let's add that to our URL. And let's see how it looks. He's not happy with some JSON. Oh yeah, okay. So again, remember what I said earlier? We have to do some kind of conversion here. We're going to convert that to a string so that it can be JSONized. Because if we don't convert that into a string, that's what he says. Interval is not JSON serializable. So what that means is that when he's dealing with intervals, such as, well, the brackets that we're defining, what I call bracket equals that intervals. For example, 5 to 10. This is the way it will look. He cannot turn that into JSON. So you have to turn that into str so that he can turn it into JSON. And that's why we do as type str here. Okay? And now it works. That's where the orientation comes. There we go. So here, as explained in this dashboard, we have female, bracket, salary, bracket, salary, bracket, salary. And see, that's what I was explaining before. That's why we're doing the drop gender here. Otherwise, we would have F, 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 which is kind of redundant. So now we have information about males and females, or should I say, men and women's salary, average salary per bracket of years of experience. Let's format that a bit better because I don't really like the way this looks. We're going to use our... Now the reason why I'm not reusing my predify bracket, I could upgrade it, but it's expecting str. Okay, and here we're not dealing with a string. That would, even though I do as type str, if I pass this in my predify bracket function, it's not going to work because it's not actually a string. So we're just going to do the replace thing manually. And we might want to add some rounding to the salary. Cool. There we go. It's much cleaner now. So let's take a look at this data. Women with 0 to 5 years of experience are making an average 140,000. Men with 0 to 5 years of experience are making an average 142. So here there is a wage gap that is favoring women. Women with 5 to 10 years of experience are making an average 140, whereas men with 5 to 10 years of experience are making an average 145. So here the wage gap intensifies. Now, women with 10 to 15 years of experience are making 147, whereas men with 10 to 15 years of experience are actually making 143. So after a certain amount of experience, the wage gap tends to be favoring women actually after 10 years. Okay, so now that we have these insights on, you know, who's being paid the most, which industry is the most lucrative, are men or women making more money, are younger people or older people making more money with the same amount of experience, well, I think we can wrap this up. So the next step is going to be about creating tests. Okay, so I am now in the test.py file of my HR API app. We're going to start with importing some stuff. Okay, that's what we're going to need. And we're going to create our test case, general statistics, test case. Okay, let's start with the setup. So the setup is going to be what's created before each time we run the test. Each time we run test, what's in the setup is going to be executed. And so typically in there, we're going to define our API client, and we're going to create a bunch of objects in the database to, well, run stuff on them. Let's go into string 1. Not really original, but whatever. Now, usually a better way to create a test is to use libraries such as Factory Boy, but or Model Mummy. But so far, we're not going to use them in the context of this video because it would make it too long, and the video is not really about testing and factories. So what's happening here? we're going to create some employees. That's going to take a bit of time. Django@email.com. Here's typo. Mail. Date. And Bob's is going to be working in industry 2. Okay. So that's our setup. Now let's create our first actual test. Yep. Test general stats API view. So reverse helps us to call a URL with its name. So for example, here, notice that I gave each path a name. So right now we will use general stats because that's what we're testing. And Django is figuring out the actual path just based on that. Let's make a GET request on it. Then we're going to make sure that the HTTP code is correct. That's 200. Now the reason why we're going to use 2 here is because remember that our data is filtered by, is ordered by industry in general stats, right? So even though we have 3 employees, results are going to look like this: industry, 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 and we have only 2 industries. So the length of our response should be 2. Now we're going to make sure that the ordering is working fine. Remember, we said that we wanted to order this response by salary. And then we're going to look at the actual math behind this. Okay, so let's take a look at this. We're actually hard coding this. So remember, we are ordering these by industry. So the first response, the first element is going to be industry 2, actually. Why? Because industry 2 is making more money, okay? And the average years of experience in industry 2 are obviously 10 because we have only 1 employee in that category. And then let's do the same with industry 1. And see here, so in industry 1 we have years of experience 8 and years of experience 5. So that's 8 plus 5, 13 divided by 2, 6.5. Now the next step is going to be a bit trickier because we're going to try to test the average age. The thing is that we cannot hard code an age because, well, age is changing every day. So if we hard code the age of these employees in the test, well, maybe tomorrow is going to be Jane's birthday and the code is going to fail. So we have to dynamically calculate the age each time. So date of birth of employees, industry 1. Employee object. Let's actually make the whole thing here. Filter industry 1. Okay. And here we're going to use value list. And here we're going to use value list because we just want to fetch the date of birth. We don't want to get the whole data regarding these employees. So that's what values list is going to do. It's going to only give us the date of birth of all the employees from industry 1. And then employee industry 1 ages. I'm going to explain that function in a second. Okay, so let's explain a little bit what's happening here. First, we are taking the age of each employee. Okay, the reason why we do age 0 is because this is actually returning a list of tuple. So we want the value of the age, and that's why we do age 0. So age 0 for age in that query set. Okay, we get that list of ages. That's the whole list of ages. And then on each of these age, we're going to do get age. The reason why is that this is kind of poorly named. We should call it actually date of birth. Now it makes more sense. This is a list of dates of birth, and we want to get the age from this date of birth, and we're going to run get age on each date of birth, and that's why we're using map, which is going to apply that function to each element of our list. And then to turn the map object into a list object, we're using list. Obviously, we're using this getAge helper function that we've defined earlier. And then we're simply going to do an average. So the sum of all ages divided by the number of elements of that list. And that's our first average. That's for industry 1. Let's do the same for industry 2. And now we're going to assert equal. So checking industries average age, industry average years of experience. So let's make sure that we're dealing with the right industries names. Where we call it industry 1. Now another way to do this would be to actually fetch the industry object and something like that, industry object get or filter blah blah blah, and we could fetch it and just do industry.name, or because we have this already set up here, we could definitely do self industry 1 name, which is actually a better way to do it. I think it's the opposite. We said that the first one should be industry 2 because of the filtering, the ordering with the salaries. Okay, something like that should work. And then last but not least, let's make sure that the average salaries are being calculated correctly. So again, that's going to be for the second industry. We have only one employee, so the average salary is 70,000. Okay, and for the first industry, that's 60,000 plus 50,000 divided by 2. That's going to be 55,000. Okay, cool. Our test is ready. Let's run it. Okay, he's not happy with something. Okay, so for some reason I had this init file in my root folder, which is messing with the path and the module discovery. I have no idea why it's there. Let's just remove it. There we go. Let's run our tests. Okay, he's not happy with this. That's status code. There's a problem with the averages. Oh, it's because we have industry 1 and 2 reversed. Okay, cool. What our tests are passing. I mean, we could have broken down this test in multiple, more modular tests, right? Because we're testing the average age, the names, the salaries. Definitely could have broken down that test in smaller modules, but that approach works too. And in the end, this endpoint is actually about retrieving all this data. So it also makes sense to put them all in the test. Now, we could make more tests for the other views, such as gender stats, age stats, but these views are trickier and we would have to deal with formatting because, as you've noticed, these views have a particular formatting. This would take much more time, and I think it makes more sense now to move to generating the documentation and then containerizing the app. Let's go. So to generate the documentation, we are going to install a package called drf-yask, which means Django REST Framework, yet another Swagger generator. Cool. Then we're going to go in the URLs file of our root folder, which is hrbro over here, and we're going to import that package. Okay, so these are what we're going to use to generate automatically the documentation. Schema view, get schema view, open API dot info. Give it a description for hrbro. Euro. Let's keep it. That's all kind of superfluous, but it comes with a boilerplate code, so let's write it. Okay. Cool. There we go. Cool. That's all kind of context information for our API. It's not the most important. And after that, we are going to add some endpoints to access the documentation. And then it's the one for redoc. Basically the same thing. And then it's the one for redoc. Okay. Cool. Let's see if it works. What's happening? Oh, the server's not running. Git link. Oh yeah. That's because we forgot to add some settings. There we go. So now we have these different endpoints, docs, but also redoc. What's happening with redoc? Template does not exist. What are you talking about? It's right over there, bro. Oh yeah, we forgot to add it here as well. Okay. So now we have redoc, we have docs, and we have Swagger. Whatever you prefer. Okay? It's all generated for us. Cool. Now the next step is going to be Dockerizing the application. Okay, let's Dockerize the app now. So we're going to create our Docker file in the root folder, which is going to be pretty simple. We're going to use Python 3.10. Work directory would be app. We are going to copy the requirements into the app work directory. Then we're going to run pip install. And then we're going to copy everything we have in our root directory, that means like our directory, in that work directory. Copy what's here, there. And then we're going to run the command to start the server. Python manage.py run server, and on this IP. Cool. Which makes me think that we did not create a requirements file. So let's do it. Pip freeze. Put it in that requirements.txt file. Okay, it's over there. And now we're going to create our Docker Compose file because we would want to run two containers, one with the Postgres database and the other one with the actual web app. So let's specify our Python version, then our services. First one's going to be DB. We're going to use Postgres 13 Alpine. Let's specify the environment for that DB. And then password. Oops. Okay. So our database is going to be called hrbro.db. User is going to be hrboss, and password is going to be a secure password called secure password. Let's specify the volumes. So here we're telling our Docker Compose, take that init SQL file in our working directory here and copy it over there in the Docker container. Obviously, we do not have this file yet, so let's create it. And this file is going to be a file that's run when the database is created for the first time. And in there, we're going to create our user. Let's go, hrbos, secure password, grant all privileges on database, hrbro db to hrbos. Okay, let's go back in the recompose. Let's define now our web service. We're going to run that command. Okay. Cool. What's wrong? Oh yeah, okay. That's going to be name, user, and password. By the way, this makes me think that we have 2 times the same command here and in Dockerize, so we're going to remove this one because it's already being executed here by Docker Compose. And this little symbol here just means that we can write commands on multiple lines. Okay. The next step is going to be about actually setting up the database in Django settings, because now we're using the DB SQLite tree, but we're going to want to change that. Okay. Let's comment that one out. All this code can be found on Django's documentation, right? I'm not inventing it or whatever. It's boilerplate code. User, password, host, port. And so it's going to be hrbos, secure password. This could optimally be in an environment variable, but again, let's keep things simple right now. Okay, cool. So that's set up. Let's try to build the container now. Okay. That's just me not having Docker running on my computer. Web failed. So what's the reason for that? Oh yeah, my mistake. Here, rename. There you go. Cool, it's building. Yeah, we forgot to install this. PsychoPG is a library that Python needs to handle PostgreSQL, basically. Let's add this. Settings. Let's add this here. And we're also going to allow localhost. Okay, cool. So now let's build the container. Okay, it just worked now. Cool, database is working. It applied on my migrations. So now let's try to verify if that database is appropriately set up. hrbos, password is secure password, database hrbro db, test, looking good. You can see that we have both tables over there and they're empty, which is normal. The database is brand new. So the next step is going to be entering the container and running our importer. Oops. Small problem with my webcam. Fixed. Let's go into that container. So Docker exec interactive terminal web1 bash. Cool. And now let's run the importer. Bam. The reason I can do this is that, remember, we copied everything from our root folder into the containers folder. So mock data is in there as well. Now, a more sophisticated way to do this would be to create an API endpoint to which we can upload JSON files and then handle that JSON file from the endpoint. But to keep things simple, we just decided to use the JSON file from the folder. Cool. As we can see, we have all our employees, which have been imported, and our industries as well. Let's try to run the test. Working fine. Let's try to, well, we've accessed the API already, but let's try to see if we can see the employees. There we go. Everything's working fine. General stats. Everything's fine.